Unit 3 Practice Test. A Ferris wheel completes a full rotation every 40 seconds. That's a Ferris wheel. Ferris wheel's day off. Remember that movie? I changed it. The center of the Ferris wheel is 55 feet above the ground. I didn't leave myself a whole lot of space, so let me just draw a circle thing with the center on it and say you're going to be 55 feet off the ground. The minimum height of a gondola is 3 feet above the ground, so that would be you at the very bottom where Drake started. You're 3. A passenger boards gondola number 8 when it's at its minimum height. Cool. What is the height of gondola 8 exactly 1 minute after the ride begins? Well, last time I checked, boys and girls, 1 minute is 60 seconds, right? So you take one complete rotation. That's 40 seconds. Now, you're here again at the very bottom, and 20 seconds later, you're at the very top. So that's where we are in this. We're at the very top. So I need to figure out how high off the ground the very top is. Well, between the center and the very bottom, we're looking at a difference of 55 minus 3, which is 52. So up here is going to also be a difference of 52. And 55 plus 52 is 107. So the maximum height of this Ferris wheel is where you're going to be after 60 seconds, and that's going to be at 107 feet. Fun stuff. The periodic function g of x is graphed below, so this is going to repeat the same exact way. I'm not even going to attempt to draw it, but it's going to repeat the same exact way every however many. What is g of 43? Well, the period of this guy is going to be 6 minus 1, which is 5, which means this whole process repeats every 5 units. So if I wanted to find out what g of 43 is, the last thing I want to do is try to draw this all the way out to 43. So let's use common sense. Okay, if this repeats every 5, then 43 divided by 5, the remainder of that is going to give us our behavior. So 5 divided by 43 is 8. 8 times 5 is 40. Subtract, we have a remainder of 3. So g of 43 and g of 3 are going to give us the same exact location. And g of 3 gives us a point of 1. So g of 43 is also going to be 1. Find the coterminal angle of negative 43 pi over 16 in the range 0 to 2 pi. So a coterminal angle, or a regular angle for that matter, is going to be something that lives in between 0 and 2 pi. Those are the same. So if I wanted to find some angle that's not in this zone between 0 and 2 pi, I either add or subtract 2 pi. Anytime I add 2 pi, I'm literally going around the same exact circle and landing in the same exact spot. So adding 2 pi doesn't change anything. Subtracting 2 pi would be the same exact thing. Now, since I live in negative land, what I need to do is add 2 pi and see if that lands me in that zone right there. Now, adding 2 pi isn't going to look so pretty here. So instead of adding 2 pi, I'm going to multiply the top and the bottom by 16, 32 pi over 16. I'm using common denominators. So let's add 32 pi over 16. By adding 32 pi over 16, that gets me negative 11 pi over 16. Now, I'm not in that sweet spot yet between 0 and 2 pi, so I keep repeating it until I land in that sweet spot. So let's add 32 pi over 16 again, and that's going to give me, no way, 21 pi over 16. 21 pi over 16 is in between 0 and 2 pi because 32 pi over 16 is 2 pi. So you would be my answer, which means you would also be my answer. The answer is A, baby. An angle with a measure of 5.7 pi would be equivalent to which of the following angle measurements? Well, any angle, right, no matter what it looks like, is going to live somewhere on a circle here. Okay, 0 and 2 pi are the same thing. So if I were to take this number and add 2 pi to it, if I were to take that angle rather, so are we giving it, so if I call it theta, if I were to take angle theta and add 2 pi, I land in the same spot. Similarly for this problem, if I subtract 2 pi, I land in the same spot. So what I need to do is I need to take 5.7 pi and subtract 2 pi as many times as I can until I run out of stuff. And my job here is to select all that applies. So I have to make my way all the way down to negative 5.7. So I'm subtracting 2 pi a bunch of times. So subtracting 2 pi gets me 3.7 pi. None of those are an option. So let's do it again. Subtract 2 pi is going to get us 1.7 pi. None of those is an option, but I did pass 2.7 pi, so words are hard. So at least I can cross that out. Let's subtract 2 pi again. That's going to get me negative 0.3 pi. So that is an option. Let's do it again. Minus 2 pi is going to get me negative 2.3 pi. So we passed u and didn't land on u, so that's not an option. Let's keep going. Minus 2 pi is going to get me negative 4.3 pi. That's not an option. Looks like all we have to do is one more time. Minus 2 pi is going to get me negative 6.3 pi, which I passed u. So D is the only option. After all of that, D was the only option that seemed to work. So D is going to be our only answer. We are given a circle here with some pieces of information. Now those pieces of information are the circle, when flattened out, goes all the way out to 6, which means I have a radius of 6 here. Okay, I have this angle A that's spun around, and after the angle A is spun around, I land on a coordinate with an x value of 2.6 and a y value of negative 5.4. This problem is asking me to find the sine of that angle. Now, there's shortcuts here, but let's remember what sine means. If we go back to SOHCAHTOA, and we're looking at a perfect right angle, right triangle like I just did, we have the opposite side and the hypotenuse. Okay, the sine of alpha is the opposite over the hypotenuse. Opposite over the hypotenuse. When I compare this to this, the hypotenuse is always going to be my radius, and the opposite in this case is going to be my y value up and down. So sine alpha is going to be the opposite, which is y, over the hypotenuse, which is r. So try to memorize the fact that your sine is going to be y over r. In this case, my y is negative 5.4 and my r is 6. So sine alpha is going to equal negative 5.4 over 6, which is going to be b. So once you have this memorized, life is going to be a lot easier when you run into problems like that. Find cosine of alpha. Well, we're given a circle here, and this circle, when flattened out, stretches all the way out to 6, which tells us this circle has a radius of 6. Now, if I take an angle and spin it around, I land on an angle alpha that also gives me the coordinates of 2.6 as an x and negative 5.4 as a y. Now, my focus here is on cosine. So we remember back from geometry that SOHCAHTOA, the ca is the cosine, and the ca stands for the adjacent side. Okay, this would be the opposite side, and we're focusing on alpha right there. That's the opposite side, and you're the hypotenuse. Ca stands for adjacent over hypotenuse. So cosine is the adjacent side over the hypotenuse. If we're comparing these to things on a coordinate plane, the adjacent side would be the x value, and the hypotenuse would be the r value. So cosine of alpha is going to be the adjacent side x over the hypotenuse, which is r. So memorize that. Memorize that cosine is x over r. Once you do that, I can look at this information over here and say, all right, well, my r is 6 and my my x is 2.6. So cosine alpha is going to be 2.6, my x value, over regular 6, my r value. And that is going to give me a over here. A. That's how you do it. In the xy plane, angle ABC is an angle in standard position with terminal ray BC, which intersects the unit circle at the point with the coordinates 0, 0.6, 0, -8. Let's draw ourselves a unit circle quick. A unit circle has a radius of 0, so we can put a point over here that's 1, 0, and we can say that my radius is 0. What I'm doing is I'm making an angle that the ray of the angle lands on the point 6, -8. 6, -8 lives in quadrant 4. So this angle that I'm calling, I don't have the name of the angle, so I'll just call it alpha, is going to spin around, spin around, spin around, and land somewhere over here at the point 0.6, -0.8. You are my x value, you are my y value. Now it's asking us which of the following descriptions is correct. Each of the descriptions is talking about sine. So the sine of an angle is going to be the y value over the r. In this case, my y value is -0.8. My r is 1. So sine of an angle is going to be -0.8 divided by 1, which is -0.8. So the sine of this angle is going to be -0.8. The answer is D. What is the cosine of 5 pi over 6? If you haven't memorized the unit circle yet, you need to. Now let me draw out the unit circle so I can visualize this better. Okay, terrible job by me, but you know what, beggars can't be choosers. You're 0, you're pi, which means you're pi over 2, which means you're 3 pi over 2. When you're dealing with the unit circle, every quadrant has 3 dots living in it. Now I care about the angle 5 pi over 6. The angle 5 pi over 6 is more than half a pi but less than pi, so we're thinking quadrant 2 thoughts. All right, every quadrant has 3 dots that we're focusing on. Okay, 5 pi over 6 is going to be that dot right there. Okay, so the angle that's created is this angle right here, and 5 pi over 6 is going to be that one. Now, when you build the coordinates on a unit circle, what you're doing is you have an x and you have a y value. I always start with the x value. I'm not hyper-focused on positives or negatives right now. I'll deal with that in a minute. But the way that I handle these is I always build from the x value and work my way up at 3 pi over 2. You would be 2 pi over 2 and then 1 over 2. I'm sorry, root 3 over 2, not pi. Root 3 over 2, root 2 over 2, and 1 over 2. And then I work my way down with the y's. Okay, so again, let me show you that. Let me just quick show you that. Root 2 over 2, 1 over 2. Then I work my way with the y's by doing the opposite. Root 3 over 2, root 2 over 2, and then 1 over 2. Now, this is quadrant 2, which is the negative x value and the positive y value. So I'll make sure I throw negatives in front of u. Now, we're hyper-focused on this point right here. Cosine is the x value. Okay, so you have a cosine theta, you have a sine theta, and cosine is the x value, and that's what we want. So what I'm going to do is, since I care about this point right here, is I'm going to label the x value right there at that point, which happens to be negative root 3 over 2. So the cosine of 5 pi over 6 is going to be negative root 3 over 2. And that's how you do it. What is sine of negative 3 pi over 4? Well, first things first, I don't like negative 3 pi over 4. So I'm going to change that, okay, so that I have something within 0 and 2 pi. What I do is I could take negative 3 pi over 4 and add 2 pi to it. Now, adding 2 pi does me no good, so what I'll do is I'll add 8 pi over 4, and that gets me 5 pi over 4. So now I'm being asked the question, what is the sine of 5 pi over 4? This is unit circle stuff. If you don't know your unit circle, memorize it. You're going to need it. I like drawing it out every time because my ADHD brain needs me to. So here's a unit circle. You are 0, you're pi. You are pi over 2, and you are 3 pi over 2. 5/4 lives in between pi and 3 over 2. So 5 pi over 4 is going to live in quadrant 3 somewhere. Whenever you're looking at a unit circle, every quadrant has 3 dots that you're focused on. Okay, 3 dots that you're focused on. 5 pi over 4 is going to be an angle that stretches around here and lands on that middle dot. That is my 5 pi over 4. Now what I do is I need to build my coordinates for these. So I like to build the coordinates by using this method that I do because it helps, again, my ADHD brain. Okay, I have 3 points here. That's the first parentheses, that's the second, that's the third. I'll worry about negatives and positives later. Right now, I just want to build my numbers. Always start out with the x value closest to the x-axis and make that root 3 over 2. Then you build it. Root 2 over 2, root 1 over 2 is 1 over 2. Then you go backwards with root 3 over 2, root 2 over 2, and then root 1 over 2, which is 1 over 2. This is quadrant 3. Everything in quadrant 3 is double negative. So negative, 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 negative. I care about 5 pi over 4, which is going to be this quadrant, or this coordinate right there. I also care about sine. Points on a coordinate plane are given to you as cosine theta, sine theta. So sine is going to be my y value. So more specifically, I care about negative root 2 over 2. Which means at the end of the day, sine of negative 3 pi over 4 is the same thing as 5 pi over 4, which is going to be negative root 2 over 2. Easy peasy. Actually, it's not, but fun pun, which I do a lot of. Like and subscribe. An angle in standard position is given by theta equals pi over 6 radians, and the circle is centered at the origin with a radius of 4. What are the coordinates of the point of intersection of the terminal ray of the angle and the circle? All right, well, a regular coordinate, now I'm given 4 possible coordinates here. A coordinate usually in xy form, when you're thinking trigonometry thoughts, is given to you as r, the radius cosine theta, as your x value, and r, the radius sine theta, as your y value. I already know that r is 4. That's going to make life easier. What I need to do is I need to see what happens when theta is pi over 6. So I go over, I look at my unit circle, okay? Pi over 6, keep in mind, is going to be in quadrant 1, and pi over 6 is that first dot. That first dot is going to be the point root 3 over 2, 1/2. I care about both of these. Both of these. So if I want to find my x value, I'm going to do that x equals r cos theta, and y is going to equal r sine theta. So let's focus on x first. X is equal r, which is 4, cosine theta, which is pi over 6. The cosine of pi over 6 is going to be root 3 over 2 because it's the x value over here. So 4 times the square root of 3 over 2, which simplifies out to 4 over 2 is 2 root 3. Okay, so that's going to be my x value. My y value is going to be done similarly. Y is going to equal my radius, which is 4, times sine of pi over 6. Sine is the y value, which is 1/2. So 4 times 1/2 is 2. So x is 2 root 3, y is regular 2, which gives us the point 2 root 3, 2. Which is going to be A. Isn't that fun? In the xy plane, the terminal ray of angle theta in standard position intersects a circle of radius r equals 6 at the point 3 root 2, 3 root 2. What are the values of theta and r? Well, what I know is I know that if I have a point, my point is going to be in the form r cos theta for x, so the radius times the cosine of my angle. And my y value is going to be r sine theta. Okay, I know in this case that r is 6, right? I also know that x is 3 root 2, and 3 root 2 is also y. So the equation that I'm going to set up, when I normally would set up x equals r cos theta and y equals r sine theta, I'm going to set up two equations. So let's do it one at a time. My x value is 3 root 2. My r is 6, and cosine theta is cosine theta. Divide everything by 6, divide everything by 6, and you're going to end up with cosine theta equals 3 over 6 is a half, so root 2 over 2. Now we do the same thing over here. Okay, my y in this case is also 3 root 2. So 3 root 2 equals 6 sine theta. Divide everything by 6 like we did last time. 3 over 6 is a half, so root 2 over 2 is going to equal sine theta. So basically, I need to think, all right, well, where on the coordinate plane do I have an x value of root 2 over 2 and a y value of root 2 over 2? So we draw out our unit circle. X and y are both positive in this case, so we're talking about quadrant 1 here. And so in quadrant 1, we have 3 possible points. U would be root 3 over 2, a half. U would be root 2 over 2, root 2 over 2. And U would be 1/2 root 3 over 2. U are the one that we want. U happen to be exactly halfway between 0 and pi over 2. And half of a half is a quarter, so the angle that I care about is going to be pi over 4. So my angle is pi over 4. I already know what my radius is, so I don't know why that was even an option, but that leaves me with A here. So pretty fun stuff. I like it. The figure shows a circle of radius 6 along with the origin and 3 labeled points in the xy plane. If the coordinates of x are 3 and negative 3 root 3, so let's write that out, what is the measurement of angle AOX? Well, this is what we know. We know that if we're talking about unit circle type things, we're also talking about angles, and we're also talking about an xy point that we are given. So here's my xy point. We know that the x value is r cos theta, and the y value is r sine theta. So what we do is we take the fact that, well, all right, well, r cos theta is the same as 3. So let's write that out. R cos theta is the same as 3. And we also, and by the way, well, we'll get there. We also know that r sine theta is the same as negative 3 root 3. What else do we know? Well, we're told that r is 6. So we can substitute that in, and now we can do a little bit more math. 6 cos theta equals 3. Now let's write that out over here. 6 sine theta equals negative 3 root 3. Let's focus on solving this guy completely first, and then we'll take it from there, and then we'll get to the next one. If we divide everything by 6, divide everything by 6, cross U out, cos theta is going to equal 1/2. Okay, now over here, we have divide by 6, cross U out, sine theta equals negative. Now, 3 over 6 is 1/2, so root 3 over 2. So let's view this again as a point. We can see from the picture, and we can see from this guy, that this is the point where we have an x value of a half and a y value of a negative thing, and if it's positive, negative, that lives in quadrant 4. And if you're thinking quadrant 4, and let me get rid of this point so I don't have to look at it anymore. Whoa, where's my eraser? Why isn't my eraser working? That was weird. If I look at this point, I have other points living in quadrant 4. So I look at these points right here and I focus, all right, well, this point right here would be the same as, and I like to build these and then deal with these, with the negatives and positives when I do. So let me quick do that. Always build the x-axis first, and you start, the point closest to the x-axis, and you start out with root 3 over 2, root 2 over 2, root 1 over 2, which is just 1 over 2. And then you work your way back. Root 3 over 2, root 2 over 2, and root 1 over 2, which is 1 over 2. Quadrant 4 gives us write 1 down something. So this is going to be positive, negative, positive, negative, positive, negative. Okay, and this guy matches up with that point right there that we kind of automatically assumed. Now, that is the first point after crossing over 3 pi over 2. After crossing over 3 pi over 2, that first point is going to be the angle 5 pi over 3, which is going to be D. Crazy stuff. Where is f of x equals cosine x concave down on the interval between 0 and 2 pi? Let's graph cosine x, shall we? Cosine x starts up here, goes down, comes back up, repeats. All right, now let's label everything that we know. If it's a regular cosine x, it starts up here at 1, bottoms out at negative 1. Its period is 2 pi, which means halfway through is pi, and it crosses the x-axis at pi over 2 and 3 pi over 2. And of course it repeats, but again, we're just only, caring about between 0 and 2 pi. I care about where it's concave down in this case. So in this particular problem, it's going to be concave down between u and u. That's concave down, now you're concave up, and now you're concave down again. So those intervals, plural, those intervals are going to be between 0 and pi over 2, and also 3 pi over 2 and 2 pi. And I guess technically in this problem we should include the 0 and include the 2 pi because we're including it here, but that wasn't given in the option, so I'm not going to lose sleep over it, but that would be the case if we're talking about concavity. So yeah, in the end, the answer is C. This problem is but. We are given an angle theta in standard position as shown in the figure below. So here's my figure. It's nice, it's spun around, lives somewhere in the fourth quadrant, yippee-i-o. The function g is defined by g of a equals sine a. So we'll deal with that in a minute. For an angle alpha, which is me, not shown, alpha is in between theta and 2 pi. So there's some angle in between here, right? That's also spun around that lives right there. Which of the following is true? So we have, you plug in alpha, you get some information, and then we'll see what happens. So let's see what they're trying to ask, all right? You're going to plug in some point. You're going to plug in some point, and you're going to use the sine function to get something. Now, the sine function is going to be a y value. So when you look at these 2 points, you have this point which has to do with theta, you have this point which has to do with alpha. You're looking at these 2 points, which means what you get, the y value, is going to be g of theta here for this one, this black dot right here, and this red dot, the y value, is going to be g of alpha. What happens here is if we're looking at y values again, no matter where I put this dot, and let's see if it'll let me move it. Will it? No, it won't. Let me see if it'll, here, let me try this button. There we are, all right. So what this is basically saying, okay, is I could put a g of alpha anywhere between u and u, but no matter where I put it, it's going to be above g of theta. So in this case, no matter what happens, since sine is y, g of alpha is going to be higher than g of theta, which means g of alpha is going to be greater than g of theta. So a very bizarre problem. Not a huge fan of it, but these problems do show up like on AP Precalculus Practice Tests. So that's why I put it here. So hope my description helped a little bit. For the function f of theta equals cos theta, what are all values of the domain when f of theta equals 1? Let's look at this from a graphical point of view. So let's draw out cos theta. All right, cos theta starts up here at 1, and then bottoms out, reappears, bottoms out, reappears, and blah-de-blah-de-blah. Bottoms out at -1, and it has a period of 2 pi. So u would be 2 pi, so u would be 4 pi, so on and so forth. Okay, you're 0. Now we care about when this is equal to 1. Okay, so when f theta is equal to 1, we have this line right here. What a perfect line that I just drew. So these points, these graphs intersect at 0 and 2 pi and 4 pi. And if we were to keep going, 6 pi, 8 pi, all the even pi's. So the answer for this one is going to be A for those reasons. So again, you're looking at where my regular cosine function intersects 1, and that happens every 0, 2 pi, 4 pi, every even pi, including the negatives if that's what we had to do. But yeah, that's your answer. A sinusoid has been vertically shifted and has the following maximum or minimum values. Maximum value is 40, minimum value is 28. Now a sinusoid is basically a sinusoidal function, looks like this. So you move it up where your maximum is now 40 and your minimum is now 28, like so. Which is the equation of the midline and the amplitude of the sinusoid? Well, the equation for the midline is given to you as a y equals, because it is an equation, y equals whatever your maximum value is plus your minimum value is, and it's divided by 2. The midline is the line that directly cuts your sinusoid in half. So you're kind of thinking it as the average, and that's what I get here. So my maximum value is 40, my minimum value is 28, divided by 2. We add those up to get 68, and 68 divided by 2 is 34. So my midline is the equation y equals 34. That's my midline. My amplitude is going to be very similar, but it's half the distance of the total max to min. Okay, so it's going to be from here to here, but half of it. That's the amplitude. So we will say that the amplitude is going to be the maximum minus the minimum all over 2. So 40 minus 28 all over 2 is going to be 12 over 2, which is 6. And so my amplitude is a height of 6. So midline is y equals 34, amplitude is 6. The answer is A. The daily low temperature of a certain city over a period of time are modeled by the sinusoidal function in the xy plane. Sinusoidal function looks like this. Much better than that though. The minimum daily temperature is 18 degrees. The maximum daily low temperature is 50 degrees. Based on these temperatures, which of the following is the best value for the amplitude of the sinusoidal function? Well, the amplitude is basically you take the maximum value, subtract out the minimum value, and divide it by 2. You're looking for not the total height, but half the total height. So in this case, my maximum value was 50 minus my minimum value was 18. Divide that by 2. You get 32 divided by 2, which is going to be 16. So the answer is C. The figure shows the graph of a periodic function f in the xy plane. What is the frequency of f? Well, in order to find the frequency of f, we must first find the period. The period is how long it takes for the function to completely repeat. So if we look at 0 and see how it's matched up with 3, it completely repeats at 3 again 8 units later. Okay? Now what the frequency is saying is like how many rotations or how many periods would you get for every 1 unit. But a better way of looking at it is that the frequency is going to be 1 divided by your period. So in this case, the frequency is 1 divided by, since you were 8, 8. And that's going to be A. Which of the following statements is true about the graph of the function f of theta equals 3 sine theta? Well, 3 sine theta has one change, and that's the amplitude. Okay, sine normally looks like this, so I'm just going to draw a normal sine function like so. But since there's a 3 in front of it, that is a vertical transformation, or rather a vertical dilation, and it goes up to 3 and down to negative 3. Okay, repeats at 2 pi, you would be regular pi, peaks out here at pi over 2, bottoms out here at 3 pi over 2. Okay? So, we need to find the true statement. Okay? The amplitude is 6. Well, the way you find the amplitude is you take the maximum value, which is 3, and subtract the minimum value, which is negative 3, and divide that by 2. 3 minus negative 3 is 6. 6 divided by 2 is 3. The amplitude is 3, not 6. You're not a true statement. And again, we can see that because the amplitude is half of the total height. The function is above the x-axis on the interval pi over 2 and 3 pi over 2. Well, at pi over 2, here, we are above the x-axis, but it dips below the x-axis at pi and is now below the x-axis at 3 pi over 2. So this is not a true statement because it's only above the x-axis between 0 and pi. So you're not true, which means you're not the one I want. The absolute maximum is when f of theta equals 3. Well, there's 3. It's going to be the absolute maximum right there. That is a true statement. Now let's look at see why D is not false. Or not true. The limit as theta increases without bound is 0. So the limit as theta approaches infinity is going to be 0, which says that this is going to at some point level out to 0, which it never will because it's going to keep on going up and down and up and down and up and down forever. So there's no limit as theta approaches. It just keeps going up and down. So D is not true either. So that's why C makes sense. Which of the following statements is false about the graph of the function f of x equals negative 4 cos x? Select all that applies. So, okay, so we could have several. So we're kind of playing 3 truths and a lie, or maybe 2 truths and 2 lies, or a bunch of lies, and it's all very anti-biblical if you ask me. I don't like it. But, oh my gosh, I'm leaving it. I'm leaving it in the video. Let's try to draw what negative 4 cos x looks like. First off, it's negative something cos x. Cos x usually starts up here, but now it's going to start down here. It's going to come back up, work its way up, come back down, repeat. Now, since it's negative 4 cosine x, it starts at negative 4 and peaks out at positive 4. All right. Nothing happens inside the parentheses, so the period is still 2 pi, which means it bottoms out at 2 pi, so it peaks out at regular pi. It crosses over at pi over 2 and crosses over at 3 pi over 2 like that. All right. So I have my graph. Let's find out what's true. The amplitude is 4. All right, so amplitude is half the distance from the very top to the very bottom. So to calculate amplitude, we would do 4 minus negative 4 over 2, which is 4 plus 4, 8 over 2. The amplitude is 4. Okay, oh, here, let's do this. Yeah, now no one will see that I almost circled it. That's true. We want the lie, so I don't want to circle you. The point 0, -4 is on the curve. Well, here's 0, -4, and yeah, it's on the curve. So since you're true, I don't want you. F of x is less than 0 on the interval 0 to pi. That means it's underneath the x-axis on 0 to, did I say 2 pi? Pi over 2 is what I meant to say. So here's 0, here's pi over 2, and it is under 0. It is under the x-axis, so this is also true in thick lettering. And last but not least, this has got to be a correct statement. F of x is concave up on pi over 2 to 3 pi over 2. So pi over 2 to 3 pi over 2 is actually concave down. So none of these, oh, it's false. I am failing at my own problems that I created. That's a lie, which means it's false, which means that's the one that I want. Whew. Make sure, make sure you like and subscribe and don't make fun of me in the comments. Or do make fun of me in the comments. Comments are good, so whatever you want to do. Which sinusoidal equation matches the graph below? All right, well, since I don't see anything being added or subtracted inside the x or whatever, this is going to take on a normal looking shape. It starts up here. And when it starts up there, that tells me that is a positive cosine x. Sine starts at 0, 0. Cosine starts above it. Now, not only does it start above it, it starts 3 units above it, which means as long as nothing shifts up or shifts left or right or shifts down, I have just a regular old 3 cosine x. I'm not worried about a change in a period. I'm not worried about any moving left or up or down or anything like that. I'm just worried about it starts up here, it goes up to 3, bottoms out at -3, repeats every 2 pi, like it does right there. Everything is good. Everything is kosher, fine and dandy like sour candy. The answer is B. Which sinusoidal equation matches the graph below? Here's my picture, and it looks like I'm not only dealing with amplitude stuff, but I'm dealing with periodic stuff, like I'm changing the number in here. So let's compare it to this function, y equals, and then I'll say a times whatever trig function is that we're dealing with, and then leave it at bx. Now, in later sections, you will have stuff going on inside and outside the parentheses. That has to do with a vertical or horizontal shift. We're not dealing with that here. We're only caring about 3 things. Thing number 1, what is the amplitude? Thing number 2, is it sine or cosine? And thing number 3, what is that b? Now, we find that b by doing 2 pi over whatever the period is. Okay, so that's how we're going to figure all 3 of these things out. Now, let's find out the amplitude first. The very tippy top is 3, the very bottom is -3, and the amplitude can be found by doing 3 minus -3 all over 2, which is 6 over 2, which is 3. The amplitude is half the distance from the top to the bottom. So the amplitude is going to be 3. Now, in this problem, since there's no shifting left or right, it starts right here at 0, 0, and then comes back up and down. It doesn't start up here. So this is going to be a sine function given the information that we have. And so I'm going to say this is sine. Now, last but not least is I need to find the period, so that I can plug it into that equation right there. If I do start at 0, go up, down, and repeat at pi, that means my period is pi. So what I'm going to do is I'm going to turn this into, let me get the regular marker, 2 pi over pi, which means that b is 2. So the equation that I can set up is y equals a, which is 3, sine, b, which is 2, x. And that matches up with B, baby. Which of the following statements is correct about the function g of theta equals 10 cosine theta over 2? I want to compare this to a cosine b theta. Okay, I'm not worried about shifting left, right, or up or down, so I'm not worried about adding or subtracting anything outside or inside. This is what I'm dealing with. I also want to rewrite this guy to kind of make it match up like that. So 10 cosine b, which is going to be 1/2 theta. Now it's asking me a couple questions, some of which is going to be amplitude, period, stuff like that. Let's find out everything we need to find out, okay? We'll find out what we need to find out. We'll graph it. We'll see what happens. We'll go from there. All right, so I'm building my graph. All right, there's my graph. My amplitude is 10. That 1/2 that lives in front of theta is going to be equal to 2 pi over whatever my period is. Okay? So if I kind of like look at this and cross multiply and say, all right, well, one period is going to equal 4 pi. So now I have enough information to say, all right, it's a regular cosine. I'm going to draw out a regular cosine. We're not moving left or right. So cosine starts up here, bottoms out down there, repeats up there. Okay. We know that since the amplitude is 10, we can say that you're 10. We can say that you're negative 10. Since it starts up here, it ends at 4 pi because that's my period, which means halfway through where it bottoms out is going to be 2 pi, where it crosses the x-axis is going to be regular pi, and where it crosses the axis again is going to be 3 pi. All right, it also is talking about midlines and stuff like that, and maximum values. Well, the maximum value is 10. The minimum value is negative 10, which makes the midline halfway in between those, which is y equals 0. So I have an amplitude of 10, a period of 4 pi, a maximum of 10, a midline of nothing, and a minimum of negative 10. Which of these is true? The amplitude is 5. Nope. The period is 2 pi. Nope. The maximum value is 10. Yup. The minimum value is negative 10. Yup. The midline is 10. Nope. The period is 2 pi. Nope. The amplitude is 20. Ooh, close, but nope. And the period is 4 pi. That's correct. And the whole thing ain't. So the answer is going to be B, baby. Which of the following is correct for the function f of x equals negative 2 cos pi x plus 4? I like to compare this guy to y equals a cosine times the quantity b times the quantity x minus c, close it, plus d. Now what this gives us is a gives us the amplitude. I used cosine, the same rules apply for sine, it's fine, but cosine, cosine. B is my frequency, in other words, 2 pi over my period. 2 is a horizontal translation, in other words, move left, move right. And D is a vertical translation, in other words, move up, move down. So let me rewrite this equation so everything lines up nicely. All right, f of x equals negative 2 cosine pi times x plus 4. Now, what do we know? The amplitude lines up with negative 2. Now, you can't have a negative amplitude, so you're just going to say that the amplitude is 2. Don't overthink it. Okay? Now, in order for me to find the period, I match b up with pi. See, we're not adding or subtracting anything, so the number in front of x is still the number in front of x. So, I'm going to say that 2 pi over my period is going to equal, we'll put pi over 1. That way we can do this by cross multiplying. So we could say that pi times the period is going to equal 1 times 2 pi, which is 2 pi. Divide both sides by pi. Lots of stuff cancels out. And you have a period of 2. Okay? We're not moving left or right at all. And then now we can also say that since this is plus 4, this is a vertical a vertical translation of 4. What this also means is if we move this up 4, that D is my midline. So my midline is going to be the equation y equals 4. So amplitude of 2, period of 2, midline of y equals 4, we are going to get B, baby. That's how you do it. A table gives ordered pairs for 7 points from a larger data set. The larger data set can be modeled by a sinusoidal function f with a period of 6. The minimum values of the data set occur at x values that are multiples of 6. So you are a minimum and you are a minimum. Ooh. What is the following, which one of the following best describes f of x for the larger data set? All right. So I'm going to compare this to the equation y equals a times whatever trig function it is that we care about. And it looks like in this case we care about cosine because those are my only options. B times x minus c, close it, plus d. Now, what does each letter mean? A stands for amplitude, amplitude. B is the frequency, which is 2 pi over the period. C is a horizontal translation, in other words, moving left or right. And D is a vertical translation, in other words, moving up or down, also known as my midline. Okay, so let's see if we can find stuff out. If I were to graph this out, okay, best as I can, and it's not going to be pretty, we have 0 at -4, and then 1 is -1, and then 2 is 3, and then 3 is 6, and then 4 is 3, and then 5 is -1, and then 6 is -4. Good job graphing by me. So it looks like we do have a cosine function that starts down here, bottoms out at -4, peaks out at +6. So we have to find our amplitude based off of this number and that number, which will also help us find our midline. So let's find our amplitude. Our amplitude is going to be the larger number minus the smaller number, divided all by 2. So 6 minus -4 is going to be +10. +10 over 2 is 5. Okay? That's my amplitude. My midline is very similar, but you add the numbers. 6 plus -4 all over 2, which is going to be y equals 2 over 2, which is 1. So the amplitude is 5, the midline is 1. Now, if I go up and then down, okay, this is my period right here. Okay, my period goes from 0 to 6. So in order to find B, B is going to be 2 pi over 6, which is pi over 3. I'm not moving left or right. So to build this equation, we have y equals the amplitude, which is 5, then cosine, by the way, I know that I'm not doing this completely correct. Give me a minute. Cosine of b, which is pi over 3, x minus 0, so just x, plus 1. Now here's the thing. If cosine starts here, and I'm not worried about shifting left or right, cosine's supposed to start up there. So we have to throw a negative in front of it. That's how I knew I wasn't right. So I have -5 cosine pi over 3x plus 1, which gives us a final answer of D. Given the function y equals -2 sine times parentheses 2x plus pi plus 1, which of the following correctly describes the horizontal and vertical translation? So I don't care about amplitude and stuff like that. I'm going to compare this to the equation y equals a times sine, b times the quantity x minus c, close it, plus d. What I care about here is the fact that you are going to be my horizontal translation. All right, so keeping in mind negatives make it look opposite, but this is where I care about my horizontal translation, so HT. This is going to be my vertical translation. Issue number 1, you don't look like you. You have parentheses inside the parentheses, you don't. So what I need to do is I need to make you look like 2 parentheses x something. So I have to take a 2 and rip a 2 from not only x but pi. So if I do that, when I factor out a 2, what I'm doing is dividing the 2 from both terms, which is why 2x divided by 2 leaves me with just x. Now what would happen if I were to rip away a 2 from pi? Well, you would get pi over 2 because you're dividing 2 from pi. So inside the parentheses, okay, so inside the parentheses I have -2 sine parentheses, parentheses. I now have 2x positive plus pi over 2. Now what that means is when it's positive inside the parentheses, you don't go right, you actually go left. So we're going to go left pi over 2. The easy part is the second part, and that's plus d, which is plus 1, which means we're just going to go up 1. Which I believe is going to be C. It is. Good job, everybody. You see what I did there? Which of the following sine functions matches the following attributes? The amplitude is 2, the period is pi over 3, the phase shift is left by pi over 6, the vertical shift is down 14. Well, we're dealing with the sine function, so I'm going to write out the standard definition of a sine function, sinusoidal function, whatever it's called. A sine parentheses b times x minus c, close it, plus d. Okay? A stands for amplitude, amplitude. B is my frequency, which is 2 pi over the period. C is going to be my phase shift. Okay, in other words, my horizontal translation. So this is the left or right part. And D is going to be the midline or the vertical translation, so up or down. Okay, so let's build this guy. Y equals amplitude of 2, A is 2. Sine is sine, close it. B is going to be, well, it gives me period, but I need to find 2 pi over period. So let's do a little bit of math. 2 pi over the period that we're given, which is pi over 3. Multiply the top and the bottom by 3 over pi because that's fractions. Pi's cancel out. And B is going to be 2. Parentheses. Why did I say 2? It should be 6. Ugh. 6, not 2. My gosh. So B is going to be 6. Now I have x minus a phase shift of left pi over 6, so negative pi over 6. So I'll deal with that double negative when I have to. Close it, plus negative 14, so minus 14. So cleaning this up, y equals 2 sine, parentheses, 6, parentheses, x plus pi over 6, close it, minus 14. And that, ladies and gentlemen, is going to give me A. I don't know why it took so long, but it did. I regret nothing. Thanks for watching. What is the equation for all the vertical asymptotes of y equals 3 tangent x over 2 plus 6? I'm going to handle this in a unique way. I know we can memorize tangent formulas and stuff like that, but who wants to do that? Basically, we know that tangent is the same as sine over cosine. So tangent x over 2 is the same as sine x over 2 over cosine x over 2. So things are vertical asymptotes when the denominator of a function is undefined. So what I care about is when is cosine of x over 2 equal to 0? Well, we know that cosine of any angle is equal to 0 at 2 different spots. And those 2 different spots are going to be at pi over 2 and 3 pi over 2. That's if cosine theta or whatever is equal to 0. Well, instead of theta, I have x over 2. So basically what we could do is we can set this up as 2 separate equations. X over 2 is going to equal pi over 2, And x over 2 is going to equal 3 pi over 2. Okay, cross multiply, 2x equals 2 pi, 2x equals 2 pi, divide both sides by 2, x equals pi is one of my possibilities. Similarly, cross multiply, 2x equals 6 pi, 2x, that's a 6, 2x equals 6 pi, divide by 2, and x is going to equal 3 pi. Now, tangent has a period of pi. So I can say that a vertical asymptote is going to exist at pi, and 2 pi. Oh, there you are, 3 pi, and also 4 pi, and 5 pi, and 6 pi, and 7 pi. So the equation that we can come up with is based off the fact that it's every single pi known to man, as long as the number in front of pi is an integer. Okay? So if I do something like pi plus 2 pi, you're skipping every other integer. So it's not going to be that. And nowhere did we divide pi by 2, so it's not going to be that. Now you are weird. You are also my answer. I'm not a fan of how this is given to me as an answer, but 2 pi plus 1 pi or 2 pi or 3 pi technically is correct. And technically n could be negative, so I could say 2 pi minus pi and get pi. So much pi, it's like freaking Thanksgiving over here. The graph of the function g is given in the xy plane if g of x equals a tangent b of x, b times x, minus 20, where a and b are constants, which of the following could be true. All right, let's look at our picture. Tan's supposed to look like that. It doesn't in this case. Tan is also supposed to exist between pi over 2 and negative pi over 2. It doesn't in this case. So what do we notice? Well, we notice a flip. Okay, we notice a nice little flip where it's supposed to go down and up to the right, but instead it's going up and down to the right, which tells you that a is going to be negative. So a is less than 0. Okay, thus eliminating these two guys. Now, what else do we know? Well, our guy, tan is normally supposed to be here and here. So our guy got skinnier, which means the number that's being multiplied to x is going to be greater than 1. Remember, if your number is greater than 1 inside the parentheses, that is a horizontal dilation, and that makes things skinnier. It compresses things. So a is less than 0, b is greater than 1, not u, and yeah, not u. So it's only going to be 3. So a. Solve cos x equals negative root 2 over 2 on the interval 0 to pi. All right, well, let's write it out over here where I have a little bit more space. Cos x equals, whoa, why did I leave all that space? Well, if I want to get x all by itself and there's a cosine in the way, we have to inverse cosine both sides, you guys. That's why I left all that space. So you cross out x's all alone. Okay, so now I'm being asked to find the inverse cosine of negative root 2 over 2. So let me think unit circle thoughts. All right. Cosine is negative, and remember, cosine is the x value. So cosine is negative here and here, quadrant 2, quadrant 3. I care about when it's going to be negative root 2 over 2, which is going to be that exact middle point between u and u, and this exact middle point between u and u. So if you are pi over 2, and you are pi, and you are 3 pi over 2, then the halfway distance between pi over 2 and pi is going to be 3 pi over 4. That's one of them. Okay, so that's one angle. That's that angle. The other possibility is going to be halfway in between pi and 3 pi over 2, which is 5 pi over 4. So in this case, the only one that matches up with that is C. That's how you do it. Solve the equation 2 sine x minus 1 on the interval 0 to pi. Well, let's write that out over here. 2 sine x equals 1. In order to get sine x all by itself, we divide everything by 2. And now I have sine x equals 1/2. Now, why did I go 1/2 and leave all that space? Well, if I want to get x all by itself, I need to inverse sine both sides. Inverse sine both sides. Now remember, sine is a y value. So I'm going to think unit circle thoughts. Okay? I'm going to think unit circle thoughts. Y is positive right here in quadrant 1 and in quadrant 2. I care about when the y value is 1/2. So the y value is 1/2 right here at the bottom of the 3 dots, which would mean it's also right here at the bottom of the 3 dots. The bottom of the 3 dots in a unit circle in quadrant 1 is going to be pi over 6, and the bottom of the 3 dots in quadrant 2 is going to be 5 pi over 6. So my answer is going to be x equals pi over 6, 5 pi over 6. And that's going to be A. Given the function f of x equals 5 sine x minus 3, for x is in between negative pi over 2 and pi over 2, which of the following represents the inverse function and its domain and range? So before I even consider the inverse function, its domain and range, I need to find the domain and range of regular f of x. All right, so f of x is going to look like this. We have two numbers that make things different, 5 and negative 3. Negative 3 is a midline. So if I were to draw this, all right, I have a negative 3 for a midline. It's a sine, which means it's going to start right here. And since my amplitude is 5, it's going to go up here, go up 5. So you are negative 3, so going up 5 has me peak out at 2, then bottom out, and then come back up. So if it starts at negative 3, it's going to bottom out 5 units down, which means it bottoms out at negative 8. Okay. I also already know that my domain is that. So for f of x, my domain is going to be negative pi over 2 and pi over 2. And my range is going to be negative 8, positive 2. Now I have to find the actual inverse. So here's the function. F of x equals 5 sine x minus 3. I'm going to call f of x y to make life a little bit easier. 5 sine x minus 3. Step number 1, swap the x and the y. So x equals 5 sine y minus 3. Add 3 to both sides. X plus 3 equals 5 sine y. Divide everything by 5. Divide everything by 5. X plus 3 over 5 equals sine y. Whoa, why did I leave all that space? Well, in order to get sine all by itself, or y all by itself, I have to inverse sine both sides. Inverse sine both sides. So you cross out, and now I have sine inverse of x plus 3 over 5. Now, since y is all alone, I can call it f inverse of x. So now f inverse of x looks like this. Now, when you're given f of x and it has a domain of this and a range of that, swap them. So the domain is now that, and the range is now this. So the domain is going to be from negative 8 to 2. And the range is going to be from negative pi over 2 to pi over 2. And after doing all that, it appears that our answer is A. Which of the following is the graph of f of x equals 2 inverse cosine of x? Well, the regular inverse cosine looks like this. Okay, looks like that. Starts at 0, peaks out at pi. All right. Now, if I wanted to multiply it by 2, what that does is gives us a vertical dilation, which in other words makes it 2 times taller. So 0 remains 0, and it stretches it out 2 times more to 2 pi. So the one that starts at 0 goes out to 2 pi. Nope, you're the original inverse cosine. You're in the wrong direction. You're in the wrong direction. There you is. The answer is B. Solve the equation 2 sine x plus 5 equals 4 on the interval between 0 and 2 pi. All right, let's write it out. 2 sine x plus 5 equals 4. Subtract 5 from both sides. Cross u out. 2 sine x equals negative 1. Divide by 2. Divide by 2. Sine x equals negative 1/2. Now, why in the blazes did I leave all that space there? Well, in order to get x all by itself, you have to inverse sine both sides. Inverse sine both sides. So what I need to do is figure out what the inverse sine of negative 1 over 2 is. Now remember, sine is a y value. So I'm thinking unit circle thoughts. Where is y negative? Quadrant 3 and quadrant 4. Where is my y value negative 1/2? Well, remember, you put 3 dots on either of these, on each of these, and the negative 1/2 will live on the top dot on each one. Okay, so the top dot on this one is going to be 7 pi over 6. And the top dot on that one is going to be 11 pi over 6. So x is going to equal 7 pi over 6, 11 pi over 6, which is going to be B. Bye-bye. Solve the equation 2 cos x equals root 3 for all values of x. All values of x. All right, well, let's write it out. 2 cos x equals root 3. Let's divide everything by 2. All right, and cosine x is going to equal root 3 over 2. Why leave all that space? So I can inverse cosine both sides, like so. And x is going to equal whatever the inverse cosine of root 3 over 2 is. Remember, cosine is an x value. So if I'm thinking unit circle thoughts, okay, the x values are positive on quadrants 1 and 4. All right, each quadrant has a dot, 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 and a dot, dot, dot. When the x values are root 3 over 2, those are the ones closest to the x-axis. So you would be root 3 over 2, and you would be root 3 over 2. So whatever that angle is, and whatever that angle is. And that first angle is going to be pi over 6. And that second angle is going to be 11 pi over 6. So x could happen between pi over 6 and 11 pi over 6. Now again, I left all that space. Why? Well, because it wants all the possibilities, which means if I spun you around 2 pi, that gives us 2, or what would that be? 13 pi over 6, that works, and then spin it around again, spin it around again. So I can spin 2 pi around. So they want me to use n, so I'm going to add 2 pi n to that. Similarly, I could spin u around 2 pi and get the same thing. Spin it again 2 pi and get the same thing. So I can add 2 pi n here too. So the one that gives us pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n for any integer n is going to be A. Solve the equation 4 sine squared x minus 2 sine x for everything between 0 and 2 pi. So let's write it out. 4 sine squared x equals 2 sine x. Now what I want to do is I want to subtract both sides by 2 sine x, like so. That allows u to cancel out and leaves me with a 0 on the right. On the left, I have 4 sine squared x minus 2 sine x. in both of these, I have an even number in common that we can pull out and a sign in common that we can pull out. So I have 2 sine x, parentheses. When I pull out a 2 sine x out of 4 sine squared x, that leaves me with a 2 and a sine. If I pull a 2 sine x out of a 2 sine x, that leaves me with a 1, set that equal to 0. Now, zero product property says we take each part, set it equal to 0, and solve. So I have 2 sine x equals 0, and 2 sine x minus 1 equals 0. Let's focus on one at a time. If I divide everything by 2, I still get 0 on the right, so sine x equals 0. And in order for me to get x all by itself, I inverse sine both sides, like that. Now, when is a sine value going to be 0? Well, let's think about the graph just a little bit. Sine starts here, goes up, hits the x-axis, repeats at 2 pi. Okay, so it starts at 0, goes up, hits the x-axis again at pi, and then goes back up and hits the x-axis again at 2 pi. So whenever it's 0 is whenever it hits the x-axis. So according to its graph, x is going to be 0, pi, and 2 pi, and we're including all 3 of those because we're supposed to include u and u. So that takes care of that guy. Now I have to solve sine x for this problem right here. So let's add 1, add 1. 2 sine x equals 1. Divide 2, and sine x equals positive 1/2. So if I were to inverse sine both sides, like that, this makes me think unit circle thoughts. So I'm going to draw myself a circle. That is an awful line. So let's scooch it over like that. Much better. Okay. I did it again. All right. What is sine? Well, sine's a y value. All right. So I care about when my y values are positive 1/2. My y values are positive 1/2 in this quadrant, quadrant 1, and this quadrant, quadrant 2. Okay. My y values are 1/2 if I think dot, dot, dot here and dot, dot, dot here. My y values are 1/2 at the dots closest to the x-axis, u and u. So the angle created here would be pi over 6, and the angle created here would be 5 pi over 6. So x is going to be pi over 6 and 5 pi over 6. So my total answer, 0, pi, 2 pi, pi over 6, 5 pi over 6. The answer is A. Isn't that fun? What is the exact value of cosecant pi over 6? Well, cosecant is the same as 1 over sine. So cosecant of pi over 6 is the same as sine of pi over 6. Right? Now, sine is a y value. So if I'm thinking unit circle thoughts, and I'm thinking pi over 6, that's the first dot right there on quadrant 1. So that is the point, root 3 over 2, 1/2. So the y value, the sine value, is going to be 1/2. So this is the same as 1 over 2. Multiply the top and the bottom by 2 over 1, multiply the top and the bottom by 2 over 1, and you get 2 as your final answer because it becomes 2 over 1, and C is going to be our guy. What are the vertical asymptotes of f of x equals 2 secant x minus 5? All right, this is how I like to graph these, and yes, I'm going to attempt to graph this on my terrible computer. All right, first things first, we have an amplitude of 2. We have a midline of -5, and most importantly, secant is 1 over cosine. All right, so what I like to do is let's label that information. Amplitude is 2, midline is -5. So let's actually move this guy way up here because I really don't need it. Okay, so magic happens at -5. Okay. So if you're -5, if my amplitude is 2, that means it's going to deal with -3 because that's 2 above, and -7 because that's 2 below. Now, What I like to do with these problems is I like to draw the cosine function as a rough draft. All right, so if I were to make a rough draft, cosine is going to look like this. All right, like that. Now, magic happens here. It starts at 0. It does this guy right here. It goes through the midline at pi over 2, bottoms out at pi, goes through the midline at 3 pi over 2, peaks out at 2 pi, hits the midline at 5 pi over 2, bottoms out at 3 pi, yada, yada, yada. From this, I know a couple things. My vertical asymptote is going to go through wherever cos x is 0. Okay, that happens at the midline. So that's where my vertical asymptote is going to live. So my vertical asymptotes are going to go through the things where cosine goes through the midline. So these are my vertical asymptotes. To draw the actual equation, you're going to use the peaks and the bottoms of cosine to make some parabola-looking things. All right, so like u, like u, like u, and like u. Now, I did too much. I didn't have to do near enough, or near that much. All I had to do was recognize the fact that, all right, well, at pi over 2, and at 3 pi over 2, and at 5 pi over 2, and so on and so forth, we're going to get vertical asymptotes. Now, how do I turn that into an equation? Well, let's start out with pi over 2. And every time I start to add 1 or 2 or 3 or 4, I get another vertical asymptote. So we will say plus n pi. And that's for any integer pi or any integer n. So the answer for this one is going to be B, baby. What is the equation of the graph below? Well, we have this guy right here, and it'll be very easy for us to look at this and try to figure things out. But I like to view this from the lens as like what sine or cosine graph is being used to create this, okay? If I find out that it's sine, then I have a cosecant. If I find out that it's cosine, then I have a secant, okay? So on and so forth. So I have 4 options: bang, 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 and bang. Let's find the midline, and that'll help me weed out these guys, okay? It looks like everything goes through the middle here at 1. So my midline is 1, eliminating U2. It also looks like my amplitude from the midline to the maximum or minimum is going to be 2, which doesn't help me at all. It also looks like in both of these cases, I'm shifting to the right pi over 2. Now, on first glance, my red dashed rough draft looks like a negative cosine. Okay, so I want to say, well, that red dashed line looks like negative cosine, so this should be negative 2. Let me see, cosine is secant, so secant x plus 1. However, that's not an option for us. Although this is true, that's not an option for us because they want us to shift it over pi over 2. And when we shifted cosine over pi over 2, we actually get a sine. So this ends up being 2 sine, which is cosecant, shift it to the right pi over 2, and then add that 1. So my answer here is going to be B for that very reason. Tricky, tricky. The following expressions is equivalent to f of x equals cosecant squared x over secant squared x. All right, well, cosecant is 1 over sine, so cosecant squared is 1 over sine squared x. Secant is 1 over cosine, so secant squared is 1 over cosine squared x. We have a fraction over a fraction, so let's multiply the top and the bottom by cosine squared x over 1, cosine squared x over 1. That crosses all of u out and leaves us with cos squared x over sine squared x. Now, regular cosine over regular sine is cotangent, which means cos squared x over sine squared x is cotangent squared x. And that's going to be D. What is the value of f of pi over 3 if f of x equals cos x plus 3 pi over 2? All right, so let's just plug this stuff in. F of pi over 3 is the same as cosine of pi over 3 plus 3 pi over 2. All right, well, you guys don't combine, so let's multiply u by 2 over 2. Let's multiply u by 3 over 3. So that's going to be cosine of 2 pi over 6 plus 9 pi over 6, which is cosine of 11 pi over 6. Well, that makes me think unit circle thoughts. So let's draw our unit circle. Let's remind ourselves that we have 3 dots over here, and 11 pi over 6 is going to be the dot closest to the x-axis. Cosine is an x value. So the dot closest to the x-axis is positive root 3 over 2 negative 1/2. I care about just the positive 3 over root, or positive root 3 over 2, which means we end up getting u. That was a fun problem. Which of the following are equivalent polar coordinates for the point A, 5 pi over 2? Select all that apply. All right, remember a polar coordinate is given to you as two things, a radius and an angle. You're not looking at like an x and a y coordinate, not at all. So when I take a look at this, I think myself, all right, well, we have coordinate planes, and I know they have more lines and stuff like that, but I'm not going to hyper-focus on that. I'm thinking if this was a radius of 5, and if I were to spin this around to hit that guy right there, that would give me that pi over 2. So this point right here, right, is 5 pi over 2. Which of these is the same? Well, a negative radius means we go over to that angle and we go in the opposite direction. So me going over to pi over 2, but having a negative 5 has me writing that guy out in that direction, which is not what I want. B is negative 5 root 3 over 2. So if I were to look at B and say, all right, well, B, let's go over to 3 pi over 2, which is down here. And instead of going towards it, go backwards in the other direction because it's negative. So go backwards 5, you land on the same spot. So B is an option. I'm selecting all that apply, by the way, so I'm not done quite yet. All right, let's take a look at 5 pi over 2. All right, well, if I go around, that's 2 pi, so 5 pi over 2 is literally the exact same thing as pi over 2. So C also works. 5 pi over 2 plus 2 pi is literally the same exact thing. So D also works. So we have 3 possibilities here, B, C, and D. Polars. What is the equation of the polar graph shown over here? Well, we have ourselves a circle, and a circle is either going to look like a sine theta or a cos theta. Now, A is going to be how far out this goes. This goes out to 3, so that's why all of these are 3, so that doesn't help us at all. I have to figure out if it's sine, cosine, negative cosine. Well, a cosine focuses on the x values. So a cosine fits nicely on the x. So you are the cosine version. So a negative cosine version would live over here. Now, what do the sine versions look like? They live right on the y-axis. So the positive sign would look like u. The negative sign would look like u. See how good I am at drawing circles? Now, we care about the positive sign. So this is going to be 3 cosine theta. That's going to be B. The graphs of polar functions r equals f of theta and r equals g of theta, where f of theta is 4 cos theta and g of theta is negative 4 sine theta, are given in the polar coordinate system for everything in between 0 and 2 pi. Which of the following is a possible polar coordinate for these guys when they're set equal to each other? Well, polar coordinate system, if I were to make the most generic polar coordinate system, it would be a circle very similar to like a unit circle, right? Now let's scooch this over here. Let's get rid of that straight line. If it'll let me, it will. Yippee. Now, the way the polar coordinate system works is you start out at 0, you're given some type of radius, right? So like U would be my radius and U would be my angle, and we would just spin around counterclockwise, right? So, same old things, like your 2 pi and 0, and your pi over 2, and your pi, and your 3 pi over 2, stuff like that. The graph of 4 cos theta is going to be a circle that lives on the positive x-axis. Cosine is x, so why not be a circle living on the positive x-axis like that? Okay, that is going to be the graph of f of theta. The graph of g of theta is negative 4 sine theta. Regular sine theta lives on the positive y-axis, so negative 4 sine theta is going to live right here. Now, it's probably safe to say that this is going to intersect right here. And it's probably also safe to say that that angle is literally right in between 2 pi and 3 pi over 2. So we could probably safely assume that at the very least, the angle part of this is going to be that halfway point between 3 pi over 2 and 2 pi, which is going to be 7 pi over 4. Now the length, I don't know. What I could do is I could use like midpoint formulas and stuff like that, but I also noticed that the length of it really doesn't matter. And it's at the angle that they really want. And so the answer for this one is going to be D based off of that information right there. What is the equation of the polar graph shown below? Well, this is A rows. There's 1, 2, 3, 4, 5, 6, 7, 8 petals. So a rose is either going to be given to you by 6, and by the way, why am I calling this 6? Because it goes out to 6. 6 sine n theta, or it's going to be 6 cos n theta. Now, when I have an even number of petals, that n is going to be half of the amount of petals that I have. So in this case, 8 over 4, 2 is going to be 4. Okay, now in order to determine whether this is sine or cosine, is the cosine of a rose formula is going to live on the positive x-axis, whether that's even or odd. Okay, petals. It's going to live on the positive x-axis for a cosine. This doesn't do that. Okay, it doesn't live on the positive x-axis, so this is going to be the sine version. So our answer is 6 sine 4 theta. And that's C. Which of the following is the graph of the polar function r equals f of theta, where f of theta is 4 minus 6 cos theta in the polar coordinate system for theta is in between 0 and 2 pi. All right, I like to compare these to the actual graphs of these guys. All right, so I'm going to compare this to the graph 4 minus 6 cos theta, in other words, negative 6 cos theta plus 4. Now that plus 4 tells me I have a midline of 4. Okay, it's going to go up to 6, so let me scooch this up a little bit. No, wrong one. Let me scooch that up a little bit. Where did that red line come from? Get out of here. All right, so if you're 4, then going up 6 is going to look like U at 10, and going down 6 is going to look like U at negative 2. Since this is negative cosine, we're going to start down here in negative land, live up here, and come back down. So your 2 pi, right? Your pi over 2, and your 3 pi over 2. Now, what I like to do with these is I like to draw out what I think is like a rough sketch, right? So if I'm starting out at 0, negative 2, here's 0, but going negative 2 is actually going to have me start out here. So that's my beginning, and I'm going to put B there for beginning, okay? If I were to make my way around to pi over 2, I have a point of 4. So pi over 2 is at 4. If I were to make my way to pi, at pi I'm at the very tippy top, which is 10. Okay, and then back to 3 pi over 2, which is going to be 4 again. And that's 3 pi over 2. Now what you do is you kind of make your way around things. Right now we're in negative territory moving closer to the x-axis. So what's going to happen for this part right here, we're in negative territory living closer to the, or moving closer to the x-axis. So this guy is going to start out looking like this. While we're up here, from pi over 2 to 3 pi over 2, we go further away, hit that 10, and get back closer to 4. So it's going to look like that. And then as we make our way to complete this guy, we are in positive land and then negative land. So positive land, negative land. Now I know my circle isn't perfect, but what I notice is that little loop right there. And that little loop right there tells me that the answer is going to be A. Les maisons, if you will, as our French friends would say. Les maisons. Oui, oui. Bonjour. I'll stop. Let r equals f of theta equals 3 plus 5 sine theta. This is some type of cardioid type problem. Lives on this interval. What is the average rate of change of r on the interval pi over 6, 4 pi over 3? All right, so what we have to do is we have to find f of b minus f of a over b minus a. You are my a, you are my b. So this is going to be f of 4 pi over 3 minus f of pi over 6 all over 4 pi over 3 minus pi over 6. Okay, this is going to get a bit hairy. First off, what we need to do is we actually need to find out what f of 4 pi over 3 is, and we need to find out what f of pi over 6 is. All right, so f of 4 pi over 3 is going to be 3 plus 5 sine 4 pi over 3. Now at this stage, usually I whip out a unit circle and do it that way, but I think at this stage I don't need to draw that out anymore. I know that the sine of 4 pi over 3 is going to be negative root 3 over 2. Like that. Okay, so I guess I can complete one. You know what I want to do? You know what I think I'm going to do? I'm going to turn you into 6 over 2, so I can make you 6 over 2 minus 5 root 3 over 2, and have that equal 6 minus 5 root 3 over 2. That's what I'm going to do. That's what I'm going to do, and I'm doing it. Try and stop me. Just see what happens when you try and stop me. All right. What's f of pi over 6? Well, that's going to be 3 plus 5 sine pi over 6. Sine is the y value of pi over 6, which is a half, so 3 plus 5 and a half is going to be 3 plus 5 over 2. Make you 6 over 2, so 6 over 2 plus 5 over 2 is 11 over 2. So let's put it all together. We have f of 4 pi over 3, which is going to be 6 minus 5 root 3 over 2, minus f of pi over 6, which is 11 over 2, all over 4 pi over 3 minus pi over 6. Numerator, not so bad. All you have to do is just combine these, actually, not multiply anything. Combine them, and you get 6 minus 5 root 3 minus 11. We'll clean that up. That's going to be all over. Let's multiply u by 2 over 2. So we'll get 8 pi over 6 minus pi over 6. So all of that cleans up to be negative 5 minus 5 root 3 over 2 all over 7 pi over 6. Let's multiply the top and the bottom by 6 over 7 pi. 6 over 7 pi. That completely crosses out. I could factor out well, I could do a couple things. First off, let's use a different color. U become 3 and U become 1. Okay, nothing happens with that 7 there. I could factor out a -5, so let's factor out a -5, leaving us with 1 plus root 3, that I'm multiplying the 3, so I'll clean that up in a minute, all over, that would just be 1 times 7 pi. So this becomes -15 times 1 plus root 3 all over 7 pi. Which, although my eyes are bad, I can see is A. Gross! Consider the graph of the polar function r equals f of theta, where theta is increasing in the polar coordinate system. All right, so let's draw ourselves a very, very, very basic polar graph. That always looks terrible when I first draw these out. Now that's acceptable. All right, so we're spinning around like we always do. All right. Given that f of theta is less than 0, ooh, it's negative, and decreasing on the interval, so pi to 3 pi over 2. All right, so normally, if we have a point, and let me actually draw a point and drag it out. So here's my point, okay? Let me actually drag that out. Normally, we would be like, okay, well, it's spinning around. Yeah, thank you. It's spinning around and blah, 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 blah. But here at this moment, if I'm at pi, it's telling me that it's negative, which means you live over here. And not only is it negative, it's decreasing in value. So like maybe right now it's -1, it's going to go to -2, and then -3, and then -4, or whatever. So what's happening is as it's spinning around, it's moving further away from the origin. Okay? So as it's spinning around, the distance is increasing because it's moving away from the origin. It was here in negative land, and now it's further away in negative land, and now it's further away in negative land, and now it's further away in negative land, and so on and so forth. Okay, so the distance is increasing, and it's increasing on the same exact interval. So I don't know why they threw these in there. That's not going to make sense. We're going to go with C, because that's the interval that we want, and the distance is increasing because it's going further away as you move further out. Oh, that was weird. Free response question numero uno. This problem right here is very, very, very typical for a AP Precalculus Practice exam. You see them a lot. So this is not something that I just pulled out of thin air. It's very typical for an AP Precalc exam, or at least a practice test. So you might see one like it in May. You never know. The blades of this fan rotate in a counterclockwise direction and complete 20 rotations every second. Point P is at the tip of one of the fan blades and is located directly above the center of the fan at time t equals 0 seconds. So tip, top, don't stop, DJ, blow my speakers up. Kesha. Point P is 12 inches from the center of the fan. Okay. And the center of the fan is 30 inches above the floor. Okay. As the fan blades rotate at a constant speed, the distance between P and the floor periodically decrease and increase as seen right here. So right now, we're at the very beginning. It's at the top, then the middle, then the bottom, then the middle, then the top, and then middle, bottom, middle, top, blah, 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 blah. Spinning around, spinning around, spinning around. The sinusoidal function h models the distance between P and the floor in inches as a function of time t in seconds. The graph of h and its dashed midline for 2 full cycles are shown, as seen here. 5 points A through E are labeled on the graph. No scale is indicated, and no axes are presented. So, problem A is to determine the possible coordinates, t, h of t, so like x, y, for the 5 points A, B, C, D, and E. So here's what they look like. Now, the nice thing about this problem is we know that P starts at the top, and so it gave us A to start at the top. So let's do this. Let's build our points knowing very well that the X value is T, which is time, and the Y value is going to be the height at a given moment. Let's focus on time first, and we're going to build all of our points by focusing on the time, and then we'll worry about the height when we have to. Okay, not the most traditional way of doing it, but this is the way I want to do it. I'm starting at 0. Now, it rotates 20 times per second, which means it completes an entire cycle every 1/20th of a second, which means you're going to be 1/20th. Now to find B, C, and D, you are comparing where B, C, and D are versus E. And then you're going to use a fraction to multiply it to 1/20th. So if I wanted to compare B to E, B is 1/4 of its way to E. So what we would say is B is going to be 1/4 of 1/20th of a second, which is 1/80th. So we will sneak a 1/80th right there. C is halfway in between. So C is 1/2 of 1/20th of a second, which is going to be 1/40th of a second. Last but not least, D is 3/4 of its way to E. So 3/4 of 1/20th of a second is going to be 3/80ths of a second. And I don't know why I put a 40 there. Silly me. Let's erase it. Got my mini eraser out, so let's see if I can do that without destroying too much. All right. So let me quick write that out, 3/80ths. So we have our t values. Now to finish these points out, these coordinates out, I need the height. What do I know? I know that the middle is 30 inches off the floor. I also know that the distance between the middle and that point is 12. So the very maximum is going to be 30 plus 12, which is 42. And the very minimum is going to be 30 minus 12, which is 18. So at the very tippy top, we're at 42. At the very middle, we're at 30. At the very bottom, we're at 18. At the very middle, we're at 30 again. And at the very tippy top, we're at 42 again. So determine the possible coordinates for A, B, C, D, and E. Well, A ended up being 0, 42. B ended up being 1/80th, 30. C ended up being 1/40th, 18. D ended up being 3/80ths, 30. And E ended up being 1/20th, 42. Now, again, these are all possible points. Technically, there's an infinite amount, but I think most people would rather start out with 0. I think that's the best way to go. So, problem A, donezo. Problem B, find the altitude of the data. This is much friendlier. The altitude is literally half the distance of the total height. And you calculate that by doing maximum minus the minimum, all divided by 2. So the maximum height was 42, minus the minimum height, which is 18, all divided by 2. 42 minus 18 is 24, and 24 over 2 is 12, which makes sense because we were told that the distance between the center and the tip of the blade is 12 inches. So it should make sense that halfway in between is 12 inches, which means halfway in between is 12 inches. So that's that. Last but not least, what cosine function fits the data? Now, I'm glad we are being asked the cosine because it starts out by looking like a cosine. So we don't have to worry about any horizontal translation or anything like that. No horizontal shift. We're not moving left or right. So the equation that I like to use is y equals cosine, or a cosine, parentheses b times x minus c, close it, plus d. A is for amplitude. B is going to be 2 pi over the period. C is a vertical translation, which I'm not going to worry about. And D is the midline. Now we know what the amplitude is. It's 12. So that's my amplitude. B is going to be the hard part. Now B, again, is 2 pi over the period. My period is how long it takes to complete a full cycle, which I wrote up here is 1/20th of a second. So this is going to be 2 pi over 1/20th. Now what I'm going to do is I'm going to multiply the top and the bottom by 20 and 20. That way that kills these guys out. And 2 pi times 20 is going to be 40 pi. So that's going to be my B. My midline is right there given to me. I mean, it even tells me that the dashed line is the midline. So my midline, D, is going to be 30. Since I'm not shifting left or right because this is a cosine, and cosine, a positive cosine starts at the very maximum, I'm in good shape. C is going to be 0. So let's put this together. Y equals A, which is 12, cosine, parentheses, B, which is 40 pi, parentheses, x minus 0, so I wasted a little bit of time there, plus 30. So to clean this up and finish this problem out, y equals 12 cosine 40 pi. X minus 0 is just x, so I'll just put x there, plus 30. So like I said, this is a very traditional AP Precalculus practice problem. Whether you see it in May, I don't know, but chances are you will see a problem like this at some point down the road, so I hope this helps. You are studying the motion of a simple harmonic oscillator that cycles every t equals 4 seconds. By the way, if you don't know what a harmonic oscillator is, just imagine a string, and on the bottom of the string there's like a weight or something like that, and it bounces up and down and up and down, so you can see that it's sinusoidal. Okay, you have collected a table of values representing the height h inches of the oscillator above a reference point. Write an equation in the form h of t equals a sine b times t plus c, all in parentheses, plus d. This is a calculator problem. So we're going to use sinusoidal regression in our calculator to help us figure this out. So let's go off to the side and see what happens when we do that. All right, time to get our sin reg on, which last time I checked, according to the Bible, we shouldn't sin ever. Hit stat, go to edit, and let's plug these points in. So while I plug these points in, now would be a very good time for you to run to the comments section and say, wow, that sin reg joke was absolutely hilarious. By the way, this is 11.7. If your eyes are bad, I apologize. And these are points, so 7.2. And by the way, you should be noticing that now these numbers are repeating, and that's because it's sinusoidal. It goes up and down and up and down and up and down. So make sure you don't make any typos, like I almost did just there. And keep working your way up and down until we get there. And then 11.7, and then 7.2. All right, so A is asking us to find the equation using sinusoidal regression, and then the other problems are going to ask us to use that equation to do something else. So I go to stat, I go to calc, and sin reg is somewhere down here, sine reg, there you is. And not only am I going to use this formula, but I'm going to store this regression equation so I can use it for later. All right, so let's go down to store. By the way, you never need any of this. I've never found a reason to use any of that, so I'm not sure what the point is. I'm not going to worry about it. Go down to store reg eq so we can save this into the y equals button. Hit vars, go to y vars, hit enter, and there it is. So when we hit calculate, yeah, it'll give us something, but now we can also use this for later. Okay, so we have 4.5, 1.571, 1.571, and 7.2. So let's go off to the side and write that out. All right, so we ended up with h of t equals 4.5 sine, parentheses, 1.571 t plus 1.571, close the parentheses, and then plus 7.2. Predict the height at time t equals 17.5 seconds. So that's just a simple matter of us using the equation that we stored in the calculator and finding out what happens when we plug in 17.5. Let's see what happens. All right, so B is asking us to predict the height at time t equals 17.5 seconds. So if I were to go to my graph, I'm not going to get 17.5. My bad. If I were to go to my graph or my table, I'm not going to get 17.5. Also, if I were to hit graph, I still won't see 17.5. So if I try to do the whole value thing, it won't let me because 17.5 is not on the screen. Watch it yell at me. So what I need to do is I need to extend my graph so that I can find the value at 17.5. Now looking at C, we're going to need also to use the point 22.2. So I'm going to go to my window. I guess I have to quit this first. I'm going to go to my window, and I'm going to keep everything the way it is, but I'm going to change my x max to 30. Okay? X max is now going to be changed to 30. So when I go to my graph, or I'll hit graph first, there it is. Now when I go to calc and do value, I will be able to type in 17.5. So it's just one of the flaws that the TI 84 Plus calculators have. But by doing this, we get 4.018. So let's go off and write that out. We ended up with 4.018 inches. All right. Find the average rate of change for the first 22.2 seconds. So the average rate of change formula is going to look like this. So what I need to do is I need to run to my calculator, find out what happens at 22.2, then minus, I already know what happens at 0. It's the first 22.2 seconds, so that's going to be 0. So I'm going to take whatever that number is, minus 11.7 over 22.2 minus 0. So let's see what happens when we do all of that. All right, so let's use that formula. We have the average rate of change. Now, we don't know what the average rate of change is yet until we find out what happens at 22.2 seconds. We do know we're going from 0 to 22.2. So the nice thing about this is since we have 0 there, all I have to do is look at my table to find out what happens at 0, and that's 11.7. Okay? Now, at 22.2, we can do the same thing we did for part B and type out value and do 22.2. And that's going to get us 2.92. 2.920, but we're going to stop at 2.92. So to set this up, all right, we're using the formula f of b minus f of a over b minus a. So this is going to be f of b. 2.92. So let's quit out of this and do 2.92. Now, if you remember, the table started you out at 0 with 11.7. So we're going to do 11.7 as our f of 0. Now we divide that by 22.2 and then waste our time a little bit and say minus 0. This is all we need. This is the average rate of change formula. Hit enter, and you get negative 0.395. Okay, so let's go back and write that out. All right, so what we did is we did 2.92 minus 11.7 all over 22.2 minus 0, which ended up being negative 0.395 inches per second. Okay? So that's free response question numero dos, baby. Free response question number 3 on Unit 3 practice test. Let f of theta equal sine squared theta and g of theta equals sine theta plus 1 minus sine squared theta. Write f of theta as a cosine function using a Pythagorean identity. All right, so sine squared theta is connected to the Pythagorean theorem identity, sine squared theta plus cos squared theta equals 1. So that comes from a squared plus b squared equals c squared, where you would be my a squared, I guess, you would be my b squared, you would be my c squared. And this technically is saying y squared, because, sine is y, plus x squared for the same thing, cos is x, plus equals 1 squared, and then you get that. Just thought I'd share that with you. Now what we would do is we would subtract cosine squared theta from both sides. Subtract cosine squared theta from both sides, cross you out, and that leaves us with sine squared theta equals 1 minus cos squared theta. So we can rewrite out f of theta as 1 minus cos squared theta. And that's how you do A. All right? Find when f of theta is 1 on the interval 0 to pi. All right, well, f of theta is sine squared theta, so sine squared theta equals 1. Let's get rid of the squared by square rooting both sides, and don't forget that when you square root both sides, you add the plus or minus, and that leaves you with sine theta equals positive or negative 1. So let's set up two separate equations. Sine theta equals positive 1, sine theta equals negative 1. Why did I leave all that space? Well, in order to get theta all by itself, we got to inverse sine both sides, baby. All right, inverse sine both sides. I'll do that over here, but let's just focus on one at a time. All right, so theta is going to equal the inverse sine of 1. Now, when is sine 1? Well, if we think of a regular sine function, it starts at 0, 0, peaks out, bottoms out, resets. Okay, that peaking out happens at 1, and that happens at pi over 2. So the inverse sine of 1 is going to be pi over 2. Now we do the same exact thing over here, where we inverse sine both sides, cross you out, theta is going to equal the inverse sine of negative 1. And we do the same thing that we did over here. When does it bottom out at negative 1? Well, it bottoms out at negative 1 at 3 pi over 2. So this theta is going to be 3 pi over 2. So my answers for B are going to be theta equals pi over 2 and 3 pi over 2. So that's part B. Now to do part C, it's asking us to find f of theta equals g of theta on the same interval. That means setting these two guys equal to each other. So I have got sine squared theta is going to equal sine theta plus 1 minus sine squared theta. So what I want to do is I want to move everything to one side, and let's move everything to the left by subtracting u, and adding u. Okay, I'm going to be lazy so I can save a little bit of space. I have a feeling I'm going to need it for this one right here. If we add sine squared theta to both sides and add sine squared theta to sine squared theta, that leaves us with 2 sine squared theta. Then we have on the left now minus sine theta minus 1 equals 0. So in my mind, okay, a little thought bubble that I'll bring the thought bubble up here. So pretend this is my head over here with a thought bubble. Is I don't like all that sine stuff. So why don't I pretend that that looks like 2x squared minus x minus 1 and then factor that out. Well, that would be a really good idea. And if you were to factor that guy out, that guy would factor out to 2x regular x. If we make that minus 1 and plus 1, I think that would work. 2x squared minus 2x plus 1x minus 1, that'll do the job. So taking this guy, and instead of x using sine theta, this factors out to 2 sine theta plus 1 times sine theta minus 1 equals 0. All right, so where I have this space over here, okay, and let me get rid of that. Let's use all the space that I can. I'm going to set up my two separate equations. So I have 2 sine theta plus 1 equals 0. And then I have sine theta minus 1 equals 0. Minus 1, 2 sine theta equals negative 1, divide 2, sine theta equals negative 1/2, inverse sine both sides, like so. And now my job is to make a unit circle over here and try to find out what happens when the y value is negative 1/2. Now, if a y value is negative 1/2, that's going to happen in quadrant 3 and quadrant 4. Negative 1/2 is going to be, and again, this is the y value. You have your dots here and your dots here. -1/2 is going to be, for a y value, the dot closest to the x-axis, so these two guys. That gives me 7 pi over 6 and 11 pi over 6. So theta in this case is going to be 7 pi over 6 and 11 pi over 6. Now we got to do this guy. Let's add 1 to both sides, cross you out. Sine theta equals 1. Inverse sine, both sides. Inverse sine, both sides, cross you out. And theta equals the inverse sine of 1, which I already know what happens is pi over 2. So this is going to be theta equals pi over 2, which is here. So writing this all out in one final problem, we have theta equals, in order, pi over 2, 7 pi over 6, 11 pi over 6. And that, ladies and gentlemen, is how you do it. The height of a person riding a Ferris wheel is given by this gross, terrible equation right here, feet after t seconds. What is the height of a rider after 30 seconds? This is a calculator problem, so what we're going to do is we're going to throw that into the y equals part of the calculator and then see what happens when t equals 30. So let's do that. All right, let's type this abomination into y equals. So we've got negative 38.101. Ooh, my favorite amount of Dalmatians. Cosine, parentheses automatically pops up, 0.371. T is x, x is t, all the same thing. Close those parentheses, plus 42.576. All right. If you hit graph, not going to see a whole lot. Okay, and that's because if you look at this equation that we just typed out, amplitude is nearly 40, and our midline is above 40. So we really need to adjust our window to make life easy for us. Now, looking at A, B, and C, the x values, which is the seconds, is going to reach around 30. So let me keep my, well, actually, no, let me change my x min to 0 because I don't need negatives. And let's change this to 40 to give us a little bit of cushion. All right. Now, if I have an amplitude of around 40 and a midline of around 40, I should probably have my y min at 0 because I really don't need, I mean, this is a Ferris wheel problem. You're not going to go below the ground. And let's set you to 90, and that should be pretty decent for me. Hey, I love it. I love it, I love it, I love it. What is the height of the rider after 30 seconds? Well, there's two ways you can do this. You could do table and scroll all the way down to 30, or you could do second calc value and see what happens when you type in 30, and we get 37.46965, whatever, blah, 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 blah. So we will round that up to 37.470. And we ended up with 37.470 feet. Very good, very good. When will the rider first get to 50 feet in the air? So I'm going to build a second equation and find out where 50 and this gross line intersects. Part 2 is going to be us finding when we hit 50 feet. So I'm going to go to y equals, I'm going to go to 50, hit graph again, and we can see several spots where this hits 50 feet. Now, we care about the first time that this hits 50 feet, which is going to be that guy right there. So we care about where these two lines intersect. So let's go to second, trace, takes us to calc, go down to intersect, or just hit 5, and scroll all the way to the left until you go to just the left of your intersection point, like so. Go just to the right of your intersection point, keep things nice and close. For guess, hit enter, and then you get an intersection at the seconds of 4.7625. So we'll go back, round that appropriately, and come up with our answer. And that happens 4.762 seconds. What is the average rate of change from the 11th second to the 23rd second? Well, that's going to be the average rate of change formula, which is f of 23 minus f of 11 over 23 minus 11. So this is going to require us going back and forth looking at a table in our calculator, but let's go ahead and do that and see what we get. All right, this last part is going to involve me building our average rate of change formula. We first need f of 23. So you go to second, table, scroll down to 23, find out that that's 66.505. So let's quit out, make our numerator by making a parentheses first, 66.505. 505 minus. Now let's go back to our table and find out what happens at 11, and that is 65.066. So let's quit out of that again. Okay, go back here, 65.066. Close that parentheses, hit divided by, and then we're going to do 23 minus 11 down here. Don't forget your parentheses. 23 minus 11, close that parentheses, and that ends up being 0.1199. So we're going to round that up once we get back to our original slides, and that'll be that. All right, so f of 23 ended up being 66.505 minus f of 11 ended up being 65.066. That was all over 23 minus 11. And then when we did the math, we ended up with a very small number, 0.1199 or 120. And that was feet per second. And that's because the difference between the heights at those moments was barely anything. So, yeah, that's that. And by the way, that completes Unit 3. So I hope you guys enjoy the videos. I hope this helps. Good luck on your tests. I love you. And don't forget to like and subscribe and patronize and all that good stuff. So thank you for watching.